Download this code from codegive.com, link in the description below. OK, let's dive deep into handling time zones, UTC, and daylight saving time, DST, in your applications. This is a crucial topic for any application that deals with users across different geographic locations. We'll cover the fundamentals, common challenges, best practices, and practical code examples. The fundamentals, time zones, and UTC. 1. Time asterisk. At the most basic level, time is a continuous flow. Computers represent time as a numerical value, typically the number of seconds, or milliseconds, or nanoseconds, since a specific epoch, reference point. The most common epoch is January 1, 1970, Midnight Coordinated Universal Time, UTC. This is known as the Unix epoch. 2. UTC, Coordinated Universal Time. UTC is the primary time standard by which the world regulates clocks and time. It is essentially the modern version of Greenwich Mean Time, GMT. While often used interchangeably, there's a technical difference. GMT is a time zone, while UTC is a time standard. UTC is not affected by daylight saving time, DST. It remains constant throughout the year. UTC is the foundation for all other time zones. Other time zones are defined as offsets from UTC, example UTC plus 1, UTC 5. 3. Time zones asterisk. A time zone is a region of the globe that observes a uniform standard time for legal, commercial, and social purposes. Time zones are defined by their offset from UTC. For example, Eastern Standard Time, EST, is UTC 5. Time zones are not static. Political and economic factors can cause time zone boundaries to change. 4. Daylight saving time, DST. DST is the practice of advancing clocks during the summer months so that evenings have more daylight and mornings have less. Typically, clocks are advanced by 1 hour in the spring and set back by 1 hour in the fall. DST is not universally observed. Many countries and regions do not use it. Even within countries that do observe DST, there can be exceptions. Example, some states or regions within the US do not observe DST. DST transitions introduce significant complexity to time zone handling. 2. Why is time zone handling important? User experience. Users expect to see times displayed in their local time zone. Displaying times in UTC or an incorrect time zone can lead to confusion and frustration. Data accuracy. Storing dates and times without considering time zones can lead to data corruption and incorrect calculations. Imagine scheduling an event for 2 p.m. in New York, and it's interpreted as 2 p.m. in London. Scheduling and automation. When scheduling tasks or events that span time zones, correct time zone handling is essential to ensure they execute at the intended times. Reporting and analytics. Analyzing data across different time zones requires careful consideration of time zone conversions to ensure accurate reporting. 3. Common pitfalls and challenges. 1. Naive dates and times. Using dates and times without explicit time zone information, often referred to as naive date times, is a recipe for disaster. The application has no way of knowing the intended time zone of these values. 2. Incorrect time zone information. Using outdated or incorrect time zone databases can lead to errors in time zone conversions and DST transitions. 3. Ignoring DST transitions. DST transitions introduce gaps and overlaps in local time. Gap. When clocks are advanced, there is an hour, or more, that effectively disappears. For example, when clocks go forward from 1:59 a.m. to 3 a.m., the time between 2 a.m. and 2:59 a.m. does not exist. Trying to represent a time within this gap will lead to errors. Overlap when clocks are set back, there is an hour, or more, that is repeated. For example, when clocks go back from 2 a.m. to 1 a.m., the hour between 1 a.m. and 2 a.m. occurs twice. This means that a given local time can have two possible UTC equivalents. For assuming time zones are static, time zone rules change over time due to political and economic factors. You need to keep your time zone database up to date to handle these changes. 5. Performing time zone conversions manually. Avoid writing your own time zone conversion logic. Use well-tested and reliable libraries that handle the complexities of time zone calculations and DST transitions. 4. Best practices for time zone handling. 1. Always store dates and times in UTC*. This is the most important principle. Store all dates and times in your database and internal application logic as UTC. This provides a consistent and unambiguous representation of time, independent of any particular time zone. To use a standard time zone database*. The IANA, Internet Assigned Numbers Authority, time zone database, also known as the Olson database or TZ database, is the most widely used and authoritative source of time zone information. Most programming languages and operating systems provide libraries that access this database. 3. Use time zone aware data types*. Choose data types that explicitly support time zone information. Avoid storing dates and times as simple strings or numbers without time zone context. 4. Perform time zone conversions at the presentation layer*. Convert UTC times to the user's local time zone only when displaying them to the user. This keeps your core application logic time zone agnostic. 5. Handle DST transitions gracefully*. Be aware of the potential for gaps and overlaps during DST transitions. Use libraries that can handle these situations correctly. Consider providing mechanisms for users to resolve ambiguous times, example by specifying whether they mean the first or second occurrence of a time during an overlap. 6. Keep your time zone database up to date*. Regularly update your time zone database to incorporate changes to time zone rules. Many libraries offer ways to automatically update the database. 7. Test your time zone logic thoroughly*. Test your application with a variety of time zones and DST transitions to ensure it handles them correctly. V-code examples: Python. Python's datetime module, along with the pytz library, provides excellent support for time zone handling. Key points in the code. *datetime.datetime.uck now gets the current UTC time as a naive datetime object, no time zone information. This is a starting point, but you must make it time zone aware. *pytz.utc represents the UTC time zone. *pytz.timezone, America/new_York, creates a time zone object for Eastern Time. You can replace this with other time zone names from the IANA database. Common names are often preferred, such as US/Eastern instead of America/new_York. *localize, datetime_object, attaches a time zone to a naive datetime object. Crucially, this is how you specify that a datetime object represents a local time. is_DST equals none to let pytz figure it out. For transitions, set to true or false for correct DST usage. *STME zone, time zone_object, converts a time zone aware datetime object to another time zone. *strftime, formats the datetime object as a string. Important asterisk always format after converting to the local time zone to get the correct time zone abbreviation and offset. Asterisk pytz.all_time zones, a list of all time zone names in the IANA database. Asterisk DST handling, the code demonstrates how to create date times around DST transitions and handles the exceptions raised by pytz when a time is non-existent. 6. Other languages and libraries. Asterisk Java.time package, introduced in Java 8, provides comprehensive time zone support. Uses the IANA time zone database. Asterisk JavaScript intl.datetime format, built-in, provides basic time zone support. Libraries like Moment Time Zone, though now in maintenance mode and not recommended for new projects, or Luxon offer more advanced features. The Temporal API, still evolving, aims to provide a modern and robust date/time API for JavaScript. Asterisk C. .NET datetime offset, and time zone info classes provide time zone support. Notatime is a popular alternative library that offers a more robust and predictable date/time API. 7. Database considerations. Asterisk store UTC asterisk as emphasized earlier, store all dates and times in UTC in your database. Asterisk use time zone aware data types asterisk use data types that support time zone information, example timestamp with time zone in PostgreSQL, datetime offset in SQL Server. If your database does not have a native time zone aware data type, store the UTC timestamp and the time zone separately. Asterisk update time zone information asterisk if you store time zone information separately, ensure that you have a mechanism to update it when time zone rules change. 8. Important considerations for APIs. Asterisk document time zone handling asterisk clearly document how your API handles time zones. Specify whether input dates and times should be provided in UTC, a specific time zone, or as naive date times, and how those naive date times are interpreted. Asterisk return dates and times in a consistent format asterisk return dates and times in a consistent format, example ISO 8601 with UTC offset. Consider providing options for clients to request dates and times in their preferred time zone. 9. Practical example, scheduling application. Let's say you're building a scheduling application where users can create events. Here's how you would handle time zones. 1. User profile asterisk store the user's preferred time zone in their profile. 2. Event creation asterisk. Asterisk when the user creates an event, they specify the date, time, and time zone in which the event should occur. Asterisk convert the local date time to UTC before storing it in the database. 3. Event display asterisk. Asterisk when displaying the event to the user, convert the UTC time to the user's preferred time zone. 4. Reminders asterisk. Asterisk when sending reminders, convert the UTC time to the user's time zone to send the reminder at the correct local time. Summary. Time zone handling is complex, but by following these best practices, you can avoid common pitfalls and build robust applications that handle time zones correctly. The key takeaways are: asterisk store everything in UTC. Asterisk use a standard time zone database. Asterisk convert to local time only for display. Asterisk handle DST transitions carefully. Asterisk keep your time zone database up to date. Asterisk test thoroughly. By diligently applying these principles, you can significantly improve the accuracy and reliability of your applications that deal with dates and times across different time zones. Remember to choose the right tools and libraries for your specific programming language and database environment.